Hi everyone, Krishna this side. So in this video, I'll be covering a very common design pattern which is very widely used across different applications. That is a singleton design pattern. Okay, so what is basically singleton design pattern, right? Before that, why we basically need a design patterns, right? So that is the question we usually have, right? So basically, design patterns are very highly beneficial in coding development, right? So there were several reasons why we use design patterns. So see, we don't really need to be as a developer, right? So that is what I'm trying to say. So we as a developers, we don't need to reinvent the wheels, right? Because it is already invented, and this will save us time and effort. So it is going to be a reusable the code that we develop. So there will be efficiency with that as well. So maintenance also, that is almost going to help us during the maintenance of the code, because of the way we write the code is in a clear structured manner, right? Scalability is also one of the point that we can include here. Code, there will be some consistency with the code. So design pattern are really a standard ways in which we can write the code in easier and even the complex problems we can decode it in simpler manner. Okay, so there are a wide range of uses of these design patterns. So definitely I'll be covering a few of them right over here. So the first thing that I am going to cover here is the singleton design pattern. Okay, so I just have created here a singleton class, and there is a singleton test class that is also available right over here. So in this singleton design pattern, I'll write the code. So like what is the singleton design pattern and why we really need it. Those things also we cover here. Okay. So singleton design pattern actually ensures that there is only one single instance of particular class across the global instances or global point. Okay. Yes, of course, this is going to be helpful for where a single point of control is needed. Actually, what I'm trying to say is when we create a database connection, right? So definitely a single connection is what we really needed at that point. Even creating the loggings, we need a single point of instance. Caching, there are like wide range of use cases. Okay, this singleton design pattern. So, of course, this design pattern is widely used. I mean, it has various reasons also, right? So, yeah, let's see how we can develop the singleton design pattern, right? So, we can create it in multiple ways. I'll go through point by point, okay? So first, what we can try to do here is we will create a eager instantiation of this class, and we provide this as a singleton design pattern. Okay, so def c so when we want to create a singleton design pattern, right, so we need to create the constructor as a private. Okay, so I'll create a private constructor here, so that no user or no developer can create instance of this particular class, right? So that's the use cases of this private access modifier, right? So once we create the private singleton constructor of this particular class, okay, so I'll create a local variable right over here that will be going to be static. Why static? I'll explain you all the things. So it is going to be a final singleton. The instance is what I'll say here, and new singleton. Okay. Now I created the object of this particular class, and I made it as a private static final. I'll explain you why I have done that, and let's create a method which will export this particular instance. Okay, sorry for that. Get instance is what I'll write now name for this particular method, and we simply return the instance. Okay. Now we notice here that we cannot create the instance of the class, so definitely there should be some static methods that should be available to access the content that is available inside this class, right? So we made it as a static, so that whenever we want the instance of this class, we can get it using the dot operator, right? Singleton dot get instance. Through this we get the instance, and this since this instance we don't want to modify it, and that's the reason we made it as final, and as in it is getting accessed in the static method, so we created this as a static, and private is what we have added to not get accessed outside, right? So these are the things that we maintained right over here, and that's the instance. That's how we can create the object of any classes, right? So we simply return it. So this way of doing is called as an eager initialization, right? So it's actually pretty much simple, straightforward. We don't have to worry a lot about anything, and it is actually thread safe as well, because it is a final variable, final, since we added a final, so we don't have to worry a lot about thread safety and all. Once the instance is created, this is the same instance that is getting access through all the threads that is trying to get access to this particular uh, instance of this class. Okay, so since it is thread safe and all, but there are few cons, right, with this one. So since we initialize the instance earlier, the memory wastage is there, definitely, for sure, right? So as in if somehow we don't require the instance of the class at all throughout the application, but since this is getting initialized at the earlier, right, of course, with the new operator, so memory wastage is going to be there with this one. So there is thread safety, but of course the cons will be the memory wastage, right? So now let me just try to access this one in the singleton class. I'll get that instance, uh, obj1 equals singleton dot get instance. Okay, now I'll create another singleton, obj2 equals singleton dot get instance. Okay, if I try to print that system dot out dot println, if obj1 equals obj2, so this should tell us like if they are true or not, right? Now I ran it, and we can notice that both the objects are same, right? So this way we confirm that yes, the single instance is what we are getting, even if we try to create multiple objects, right? Okay, so this is like eager loading, easy to create, but memory wastage is there if we don't require the instance, right? So now what we can create, right? Like how we can load it lazily, right? That is something which we can see, right? So what we can do is, instead of creating it right over here, we will create it inside this method itself, right? So let me copy it. I'll maintain it as an instance only. Instance, let's remove the final as well, because if it is a final, it is going to be, it needs to be initialized, right? So if instance equals null, if that is the case, we will just create the instance and then return the instance, right? So this way of doing is like lazy loading. So once the method called, that time only the instance is getting created, right? But there are problems with this way as well right now. So see, we are actually now saving the memory. So if required, then only we are creating the instance. But this is not thread safe, right? Like if multiple threads try to access this instance, and they see that the instance is null, they create the instance, and each one they get new instances, and they will there is not going to be thread safe, right? With multiple threads, if they try to create the instances, they will get different kind of instances. So yes, of course, this is a problem, right? So how we can make it as a thread safe now? That is the question, right? So yes, we can use synchronized keyword. So if we put here synchronized, uh, right? Now, once we keep create this as a synchronized, this method as a synchronized method, this will be thread safe. Okay, so that is something which thread safety we achieved through the lazy loading now. But again, the problem is there, right? So if multiple threads try to access this get instance, what they have to do is they have to wait until one thread finishes its task inside this particular block, right? That's the way how synchronized work, right? So even if the instance is created, other threads simply have to wait, right? So until the first thread get the instance, the method completely finishes giving the instance. another thread has to be wait, another, I mean, if multiple threads are keep on waiting. So this way, like it is of course like performance overhead issues what we notice with this particular way, right? So even though the instance is available now, after getting created, still other threads have to keep on waiting until the first thread finishes its task. So this is like a problematic thing, right? So I mean, we don't want to hamper our performance issues as well with this one, right? So what we can do is like we can make it as a double locking system. Okay. Further, we can enhance is like instead of keeping this one as at uh, I mean, method level, what we can do is like we can simply, if the instance is null, okay, once we come inside here, what we can do is we create a synchronized block, okay. This way, let's get the singleton dot class. Now inside here, we will be setting the thread. I mean, this synchronized block. This is like a second lock that we are putting right over here. Okay, and to get it access notified that if the instance is got modified or not, we will make it as a volatile. Okay, so you guys need to know like all these terminologies and all that are available in the Java. Okay, so since we now make it as a volatile, if the instance is got modified, the state of the instance is modified, instead of getting it the information from the cache, other threads will also get updated values for the instances. Okay, now what happens here is like since we did not keep it as a class level, sorry, method level, what happens is like so, okay, multiple threads comes here on this particular method. They try to check if the instance is null. Now first thread which runs this particular line, other threads have to wait. Okay, now since it is setting as a lock, so other threads have to wait. The instance, once it receives, it will return. Now if multiple threads try to access this one, they check if instance is null. Only the first thread actually try to create the instance of it. Now once the instance is not null, right, so this value is actually filled up. Okay, the object is modified. Every single thread, once they come here, they see that okay, if it is not null, they will directly get the same instance that is been created by the first thread. Okay, so this way, like we will be the performance overhead issue is not going to be there. Synchronized only get locked for the first time when the instance is null actually, and for all the rest of the threads, since the block is not synchronized, so they will come here. They check that if instance is not null, they'll definitely get the same instance. Okay, so that's how we can actually reduce the performance overhead issue. But this is like a bit complicated way of doing it, right? So I mean, we have to maintain synchronized block again here, and we have to do a lot of crazy stuff right over here. So like it is a bit of complex, but yeah, this will serve our purpose. Okay, this is going to be one of the best way to make the singleton block and a singleton class instance to get it thread safety, and even not need to worry about the memory overhead issues or the performance issues. Okay, so yeah, this is there, but we definitely can improve this further, right? So what we can do is this is one of the recommended way, and I personally had used it in few of the applications. Okay, so what I'll do is so definitely we need the constructor private for all the time. Okay, until and unless we are not going to achieve the singleton state that we are trying to do it, right? So what I'll do is like I'll create an inner class. Okay, so there will be singleton helper here. Okay, this is my inner class. Inside this inner class, I'll simply create that same thing that we tried in the first way of doing it, right? So what I'll do is I'll create the instance here, and new singleton. Okay, so I'll explain you guys. Okay, now if the instance is null, what I'll do is rather than instance is null and all, we simply can remove that all the part, and what I'll just simply return is, because we are getting the instance from this inner class, so Yes, I'll get singleton help without instance. Okay, we will simply return this one. Okay, and we let's remove this as well. Now, this way of doing is like it's uh, definitely like this is going to be thread safe. Okay, because it is a final static final and it is not going to get modified at all, no matter how many threads try to access it, right? And since it is a private static inner class, right? So since it is an inner class, okay, doesn't matter like what it is, but yes, this since it is an inner class, so the problem that we were facing, right? So early load, eager loading, that was the issue, right? So I when I kept it outside here, so it the moment this class gets ran, the instance this will run, right? So now since it is a private inner class, until and unless this gets called, right, this particular thing that we are returning, right, this is not going to get created. Okay, this is not going to get created. So lazy loading issue is also resolved. So lazy loading is what we actually wanted, right? So eager loading issue is also got resolved here. So until this get instance get called, this is not getting invoked, and of course this code is not getting ran at all. So yes, thread safety is here now. Lazy loading is what we wanted. That is also we achieved, and the synchronization issue that we were facing, right? So that overhead is also gone. So this is like one of the best way to create a singleton class instances. Okay. So yeah, I mean these are the ways through which we can create the singleton instances, and I already told you like there are wide variety of use cases of this creating the singleton design pattern, right? So when we try to create a database connection there, we want a single instance of the class, even during the logging, caching, configuration settings, where a single point entry is needed. So these are where areas where we basically use this singleton design pattern instance creation. So that's all from this particular video. I hope you got some learning, and yeah, thank you for watching this video. Bye bye.